Okay, chapter 6, our final chapter, is going to hit upon several topics involving different kinds of functions as we kind of wrap up. Now, here's my biggest suggestion as we go through and do this last unit. I'm going to, the first worksheet 9 has sections 1, 2, and 3 on it. Okay, after you get done with each section of video and the problems associated on the worksheet for that section, my advice is to go to the test and work those questions as well, so that you're going to be completing the test while you're completing the worksheets. That way, all the information is still pretty much fresh in your mind, and you should be able to make that jump to answering those questions a little bit quicker. So we have like 7 sections to cover. Some of them are going to go pretty quickly. Some of them take a little bit more time to explain. But again, with that amount of content, covering the test as well as the worksheets as you go through might make things go just a little bit smoother. Okay, so section 1 of this assignment sheet, 6.1, is on composite functions. Okay, now you're going to see them written a couple different ways, but basically a composite is a way of taking functions and substituting one function into another. It's an operation. Okay, but instead of substituting one number or one variable in, we're actually substituting a whole function in. So you might see it look like this. If I said f parenthesis g parenthesis x, okay, this means it's the composite of f and g, where we're going to take this inside function g of x and substitute it into f. Okay, and that's important, is that because g of x is inside the parentheses, that tells us which one we're substituting and which one we're starting with. So we're starting with f and we're plugging g into it. Okay, so the other way they might write that is they'll use a little open circle. Okay, f of g of x. Okay, both of those mean exactly the same thing. Now you can switch them around. You could have g of f of x in this order. Okay, and you can also take composites of a function with itself. Okay, so if I have f of x, or g of g of x. Again, different notation, but again, both of those mean the same thing there. You're taking a function, start with the function, take the same function, plug it in for x, okay, into that function. Okay, repeat the whole function there. Now, the other thing they're going to ask you to do on some of these exercises, and they're going to start off with that, is to do some evaluating. So when I take f of g of 2, for example, it says take the number 2, plug it into g, and then take that answer and plug it into f. Okay, so we're doing a sequence of events. Again, whether we're substituting a number in or whether we're substituting expression in, just depends on whether this is an x or whether it's a number. Okay, now the most common format you're going to see are problems where I give you the equations and we're going to work with the equations, and you'll see a couple examples of those in just a minute here. The other thing you're going to see is, especially with the evaluating part, it's possible to use a table of values where they tell you certain numbers, and then what we do is we use that table to find the numbers that you would yield after you substitute. Okay, so question number 1 on the worksheet has 6 parts to it, A through F. Now, what we're going to do is we'll talk about the B, D, and F over on the side here, okay? But notice what they do here. I want to take F of G of 2, okay? So you start at the number 2. Notice on top, that's your X value. Notice that this top row is all X values, okay? The next row is what you get when you plug into F. The next row is what you get when you plug into G. So I'm going to take so I'm going to take the number 2, and I'm going to plug into G, and then I'm going to take that result and plug into F. So when I take G of 2, go over to the column starting with a 2, go down to G, and you get -3. G of 2 is -3. Now, go back up to the top row, but this time you're going to take that -3 and find it, and then go down to the F column. So I'm going 2 to G to F. So 2 to -3, and then -3 to 11. Okay, G of 2, that's how I got the -3, and an F of -3 equals 11. Okay, so I'll do it again. This time I want to start at +3, and this time I'm going to go to F first. F of 3, I get -1. Now take the -1 and find it up here on the top row. And this time I'm going to go down to G, since that's the second one I'm going to go with. And so 0, G of 0, or excuse me, G of -1, you get an answer of 0. Okay. Now, if I was given another function like H, it is possible that you can form composites over more than just 2. But they stopped it at just doing 2 to get you used to that pattern. Okay. Now, F is where you're going to plug a function into itself. So on F, we're going to just use function F. Again, starting at the number 3. 3, I'm going to go down to F. F of 3 is -1. Now you're going to take that result, -1, find it, and go down to F again, which is 7. Okay? So that's for number 1. That's what they're asking you to do. Use that table to evaluate each one of those composite functions. Okay? On number 2 and on number 3, you have A through D, each one of these. Okay? And again, you're trying to form composites. But again, follow the order. Okay? So on A, I want to find F of G of 4. So I'm going to take, first thing I'm going to do is I'm going to find G of 4. So take the number 4, go up here, plug into G. You get 3 over 4 squared plus 2, which is 3 over 18, which is 1 over 6. Now, take that 1 over 6 and plug into F. So we're going backwards here, plug into the other one here. So F of 1/6 equals absolute value of 1/6 minus 2. And use my calculator for this. I get -11 over 6, but the absolute value then Negative 11 over 6. And the absolute value then would make it positive. Okay. So a little bit messier here, but hopefully some of these other ones will work out. But again, I'm working my way from right to left. 4 goes into G, and that answer goes into F. On part B, okay, starting with the number 2 this time, I'm going to put 2 into F, which this will be a little bit easier. So F of 2 is the absolute value of 2 minus 2, which is 0. And then G of 0 is 3 over 0 squared plus 2. So you just get 3 over 2. Okay. Part C, F of 1. So F of 1 becomes the absolute value of 1 minus 2, which is absolute value of negative 1, which is right back to 1 again. Okay? And then when I take that and plug it in again, okay, the same thing happens. So the answer is going to be, for when you do it that second time, F of 1 is still going to equal 1. And then on part D, G of 0, well, when you plug in the first G of 0, you get 3 halves. Okay, now plug in the 3 halves. You're not going to plug in 0 again. 3 halves is going to become 3 over 3 halves squared plus 2. And I'm going to get a little help from the calculator on that, do all that together. And change that back to a fraction. I get 12 over 17. Okay, so start your way on the inside, work your way from right to left. Just keep substituting in. Now, you might have a little bit better luck with your answers on number 2 because they're not rational. They're polynomial, so those numbers shouldn't get as nasty, but the steps are going to be the same. You're still doing A, B, C, and D for each one of those. Okay, but so all 3 problems there on evaluating, on how to evaluate using a composite. Okay, 4 and 5 on the next page, you're still doing the same thing here, but in these examples, we're not plugging in numbers. So in that regard, it's going to make it a little more algebraic, and hopefully it'll allow us to go through the steps a little bit faster. Okay, so on number on number 5, the first thing I want to do is I want to do F of G. Okay, so this is part A, and I want to do F of G. Now, the key here is you want to start with the first one and substitute in the second one. So I want to start with F, and where you see this X, you want to substitute in the other polynomial. So instead of X, this is now going to be X squared plus 4, and then plus 1. Now note the parentheses. My only reason for putting those parentheses is to show where the original variable was. Okay, so I can still see the original expression for f, their x plus 1. It just now has some different terms in its place. So combine the like terms, and I get x squared plus 5. Okay, and that's it. Okay, so you're literally substituting a function into another one, not the answer, not the number, because there is no number provided, but the expression, and then doing the work. Okay, now the next part's going to be a little bit more tougher because I'm going to be doing the reverse. I'm going to start with x squared plus 4, and this time I'm plugging in for x. But I'm going to have to square it. So when I plug in x plus 1 squared plus 4, okay, it now looks like this, okay, and what I've got to do to this x plus 1, I've got to take x plus 1 times x plus 1. So when I FOIL that mess, I get x squared. On the outside and inside, I get 1x, and when I add them, I get 2x. And then multiplying 1 times 1 is still a 1. Okay? So x squared plus 2x plus 1, that's what you get when you square the binomial x plus 1. Bring down the plus 4. And again, combine the like terms. Okay? So when you take g of f of x, that's what you get there. Okay? Now, f of f, so again, start with f. This time I'm going to plug in f again in place of the x. So x plus 1 and then plus 1. Combine the like terms, x plus 2. And then d, starting with g this time, g of g. Plug in. And again, the problem here is going to be squaring that binomial. When you take x squared plus 4 times itself, this will be, I'm foiling, x to the 4th. Outside and inside terms, I get 8x squared plus 16. That's from just the foiling. Now take that plus 4 and add it in. Okay. So again, the ones that require squaring are definitely have those extra steps that make them a little bit more involved. As you look at number 4, you have two linear expressions, a negative x and a 2x minus 4. Okay. Again, I think as you plug those in, they're going to be much easier to work with algebraically. Okay. So should not be nearly that difficult. Okay. So so that's what composites are. That's what I'm asking you to do with them. We might have done a little bit with composites last semester in intermediate algebra. If so, I hope that makes this even easier. But from there, you see we're going to talk about inverse next, and then we'll move on to talk about exponential and logarithmic functions, and then continue to wrap up from there. Okay, again, my advice again is once you get those 5 problems all completed, jump to the test. Okay, do those problems as well. If you have questions on this or even the test questions, Questions, I will write out if I need to kind of get you going again. But that way we can kind of keep up and get everything turned in all at once. Okay, thanks.